Question 4. You'll notice this time that we don't have a tree drawn for us, so we're going to have to do that most likely. There are 5 red pens, 3 blue pens, and 2 green pens in a box. So we've got some sort of box here, doesn't matter what it looks like, and we've got 5 reds, and we've got 3 blues and 2 reds in there. Gary takes at random a pen from the box and gives the pen to his friend. Gary then takes at random another pen from the box. Okay, so he's not replacing these pens back into this box. So let's draw a tree diagram. Remember, our events are going to be our first pick, or first pen, or first pick, or first pen, and the second event is going to be picking our second pen. So we could write pick first pen, pick second pen. All right, so there's our events. Now our outcomes of each one can be one of 3 different colors, either red or blue or green. So you can either pick either one of those, and a second pen could also be either red or blue or green. Oh dear. Now notice I've kept the order the same here. You don't have to, but it's useful to do that. Okay, so for the first pen picked, we first of all notice that there are 5 plus 3 plus 2 pens. So there are 10 pens. So our probabilities are going to be out of 10. And there are 5 reds, so there's going to be a chance of a 5 in 10 reds. Notice I don't really want to simplify these. I want to keep them all as tenths. I don't want to write that as a half. Keep them all as tenths. And blues, there are 3 blues and there are 2 greens. So the probabilities are 5, 3, and 2. Now, we're not putting the pen back. We're giving the pen to somebody else. So the second set, there are only going to be 9 pens left, right? Because we've taken 1 away and given it to a friend. So all these are going to be out of 9. Now, if we've picked a pen, a red pen, so we're going down this path at the moment here. Okay, if we've picked a red pen, then, and there were 5, there was only going to be 4 left. But because we picked a red, there are still 3 blues, and there are still 2 greens. And we'll just check that this adds up to 9. 4 plus 3 is 7, plus 2 is 9. 9 ninths. Yeah, remember that these must add up to 1. Let's do these, and as will these and these down here. Now, if we picked a blue, first of all, then there were 3 blues. There's only going to be 2 left. There were 5 reds. There are still 5 remaining. And there were still 2 greens remaining. Now, if we picked a green, there were 2. We've picked 1 out, so there's only 1 left. There are still 3 blues remaining. And there are still 5 reds remaining. So that's all our probabilities on our tree. Remember to label your outcomes here and here, and your events going this way. Work out the probability that both pens are the same color. All right, so we want the probability that they're the same color, both pens, same color. Well, in which case, our 2 pens are either both red, or both green, or both blue. So we've got probability of red followed by red, or the probability of blue followed by blue, or the probability of green followed by green. So red followed by red, so this is just multiplying together these probabilities. Yeah, so that's 5 tenths times 4 ninths. Just change the color back here. And then blue followed by blue, so that's going to be this blue followed by blue. So that's going to be 3/10 times 2/9. And then finally green followed by green. So we're going to go down this arm here, 2/10 times 1/9. Okay, these are all out of 90, aren't they? 10 nines are 90. 5 fours are 20. 3 twos are 6. 2 ones are 2. Giving a total of 28 90ths. Again, we might want to reduce that fraction, 14 45ths. Question